Welcome to week number 4 of CS394R Applied Probability. And in this week, we're going to introduce the first 2 out of a 3-part series of lectures on discrete random variables. And discrete random variables are ultimately just a way to represent non-0 to 1 outcomes of a given probabilistic system. If we have a system that has an output of maybe a letter grade, A, B, C, D, or F. How do we represent that and represent what the output of a given letter grade is going to be based on some experiment? So we're now moving from the probability of something occurring into what can we do with those probabilities? How do we assign real world values to them? So in this first lecture of discrete random variables, or this first, again, of a 3-part series, we're going to talk about several aspects of discrete random variables. But first, we're going to introduce just what is a random variable. So there are 2 primary types of random variables, discrete random variables and continuous random variables. And then within both of those classes of random variables, there are different functions or different distributions. So we'll be looking at several of those as we progress through this series. We'll also be looking at probability mass functions, which are basically a way to identify the outcome probability or the likelihood of a given random variable output. So again, if we have a random variable of grades that's A, B, C, D, and F, what is the likelihood of each of those specific random variable possibilities, those outputs, occurring? We'll also look at some examples of random variables, how we utilize those in real life, and that'll be rather brief. We'll go through a lot of those in the homework to give you some great experience actually applying the concept of random variables. We'll also look at expectation and expected values. If I run a certain experiment a large number of times, say 1,000 or 100,000 times, what can I expect my most common output to be? What is the most likely output of that random variable? And then we'll close out this lecture with a coverage of expected value rules and linearity, basically talking about how we can utilize expected values as functions and what happens when we apply a function of an expected value as our output.